Hello everyone. Welcome to IS 300, and this week we're going to go into the Security Guidance White Paper, which you can find by going to the Getting Started link in Blackboard and downloading the white paper. We're going to start with Domain 1, Cloud Computing Concepts and Architectures. In this chapter, we'll cover an introduction, overview, the cloud security scope, responsibilities and models, areas of critical focus, and recommendations. Cloud computing, it's a technology or can be considered a collection of technologies. I think that's a better definition for it. It's an operational model, can be a business model. It is transformative and it is disruptive, growing very quickly, and I'm pretty certain that most, if not all of you, are using some sort of cloud computing environment. If you have a Gmail account, you are using a public cloud. The National Institute of Science and Technology has defined cloud computing as convenient, on-demand, ubiquitous network access to a shared pool of configurable computing resources such as networks, servers, storage, applications, and services, with rapid provisioning, which means they can be up and running quickly, with minimal management effort or service provider interaction. That is the NIST definition of cloud computing. ISO, the International Organization for Standardization, and IEC, International Electrotechnical Commission, have a similar definition: scalable, elastic pool of virtual resources, physical or virtual resources. Self-service provisioning. Provisioning simply means providing access to those resources. Administration on demand. Taking a set of resources, processors, memory, putting them into a pool using virtualization. So here is a diagram that I think sums it up pretty nicely. The essential characteristics of the cloud are broad network access, rapid elasticity, measured services, which means it can be considered a utility, on-demand self-services, all provided in a pool of resources that are made available to the user. There are three service models for the cloud. There is software as a service, platform as a service, and infrastructure as a service. Those three service models we will talk about all semester. Get them entrenched in your brain. Software as a service, platform as a service, and infrastructure as a service. You have four deployment models: public cloud, private cloud, hybrid cloud, and or community cloud. The resource pooling gives you a collection of resources and then allocates those resources based on permissions, policies, configuration, and things of that nature, usually set up by an administrator. The consumer then provides those resources to through an on-demand self-service. Consumers provision the resources from that pool, and they use what they need on demand, what they need when they need it. Resources typically over a network without any need for direct physical access. Rapid elasticity means that it can grow as needed. It's scalable, and it can match resource consumption with demand. It is a utility, which means it's a metered service so that the consumer pays for only what they use, just as if it were a cell phone service or an electrical service or a gas service, a utility. Three service models, as we mentioned earlier. Software as a service is applications that are deployed, developed, designed, and deployed in the cloud, managed and hosted by a cloud service provider, usually accessible through the web, using a web browser, mobile application, or some sort of client app that's installed on the desktop. Platform as a service. It hides the details but allows databases, operating systems, file storage, big data processing, application programming interface access to software as a service applications, and then infrastructure. The infrastructure is the hardware, the resources, the network, the storage, and the computing capability. Public cloud available to the general public. For example, I mentioned it earlier, if you have a Gmail account, you are using a public cloud. Private cloud, typically for a specific organization. Amazon Web Services is an example of a private cloud that can be purchased. Services can be purchased from Amazon, but it is Amazon's private cloud. Community clouds that support a specific community with a shared mission, shared policy or compliance. There might be, for example, federal agencies that use a community cloud. Hybrid cloud, composition of two or more, either public, community, or private clouds that are made available, just a combination of resources that are made available and portable through the cloud. The question is, who manages what? If it's a public cloud, typically the infrastructure is managed by a third party, it's owned by a third party, and it's located off premises. Private or community, it could be the organization and or third party for the most part. And for hybrid, it can also be organization and or third party, and trusted and or untrusted. So this simply tells you who is responsible, who manages it, where's the infrastructure, who owns it, and how is it accessible. A good way to look at a cloud computing is a stack. And I'll start at the bottom. I'll start with infrastructure first. Infrastructure composed of hardware and facilities. Infrastructure, typically cable, wire, network, routers, bridges, servers, hubs, gateways. Those kinds of devices are considered infrastructure. Platform as a service rather, is built on infrastructure. Platform is built on infrastructure. Software is built on a platform. So started with the infrastructure, the hardware and the facilities, going up the stack to the platform. The platform can include the operating system, the databases, the things that are needed to run a system, platform. And then the software is the application itself, usually a web-based, web-enabled software as a service application. So, infrastructure as a service, the facilities, the hardware, the abstraction layer is simply all the things that are hidden but are needed for example, for an operating system to run and function, or the cables and wires that are needed in the case of infrastructure. Now, the orchestration, which ties these things together, the resources together, and then there may be some application programming interfaces, also known as middleware, which remotely allows you to manage the resources and deliver those resources to consumers. Infrastructure as a service is hardware, facilities, things of that nature. Here's an example. So in the middle, you have the APIs, the management of the network, if you will. There's probably a controller for compute, controller for storage, and then there's some virtual machines. Hypervisor, simply a way to manage those virtual machines, and then a storage pool for databases and a memory and things of that nature. Platform as a service is on top of infrastructure as a service, as we talked about earlier. Gives you the ability to use frameworks, software developer kits rather, middleware capabilities, APIs, databases, messaging, queuing, the ability to send and receive inputs and outputs from a queue, part of the platform. The layer of integration and middleware built on top of infrastructure as a service, and then pulled together, orchestrated, and exposed to the customer, again using application programming interface rather, and also known as middleware. So this is a very similar diagram to the one we looked at for infrastructure as a service. The difference here being that you have the platform being the operating system and or applications that are running inside of that operating system. Software as a service. Multi-tenant applications. Multi-tenant simply means one or more customers, one or more tenants that can use these applications or develop these applications even. One or more presentation layers, which often includes the web browser or the client, mobile applications, public application programming interface access, and the logic and the data storage. Now, the common denominator between these three models, infrastructure as a service, platform as a service, and software as a service, the common denominator between these three is an application programming interface, also known as middleware. The middleware is the glue that holds these cloud service models together. All right, so there's also a logical model, if you will. The metastructure, information or data about the structure. So the infrastructure itself is the core components, including network storage and the compute, as they define it in this white paper. Metastructure, the interface between the infrastructure layer and the other layers, and again, connected using application programming interfaces. The info structure is the data and the information itself, usually in a database, file storage, things like that. Applistructure, the applications that are deployed inside the cloud and the underlying services that are used to make those applications available within the cloud. So who is responsible for what? With software as a service, the provider is responsible for security. Platform as a service, the provider is responsible for security of the platform. The consumer is responsible for things that are implemented on the platform. Infrastructure as a service, the provider is responsible for the security. The cloud user responsible for everything built on that infrastructure. So if you take a general look at it, the more mostly consumers, starting with the infrastructure stack, mostly provider as you go up the stack to software as a service. So mostly the consumer when it's handling infrastructure, mostly provider when it is the application, software as a service applications. Who is responsible for security? Primarily it's going to be the provider. So, for security purposes, identify the necessary compliance requirements. If it is a regulated environment, such as a health care organization, there are certain requirements and restrictions that must be adhered to. Or if it's a banking industry, there are definitely security requirements. Sarbanes-Oxley and things of that nature are part of it. Federal agencies, of course, have very strict security. Selecting a cloud provider and service and deployment models depends on the type of security that is needed. You can look and define the infrastructure, identify any control gaps, and make sure those gaps are filled, and any changes that happen over time. If you're deploying, if you're relying upon a cloud environment, then some of the control is taken away and it is given to the provider. So there has to be some sort of service level agreement in place. We will talk about that in future chapters. Service level agreement, which defines very carefully who is responsible for what, and it's a legally binding contractual agreement. So identifying the requirements, defining the architecture, looking at the gaps, managing the changes, all of those things are part of a very simple cloud-based security process model. So it's important to understand the differences between cloud computing and traditional infrastructure. Virtualization, or the ability to give a virtual machine to a consumer. Virtual machine hides or abstracts all of the details and gives that consumer the appearance that they have their own little operating system, their own little private application and things like that, when in fact it is part of a larger system that is simply running one or more virtual machines. Automation is a very big part of it. A lot of the security and controls are automated processes, or at least they should be. The upgrading of systems and making sure that patch management has been handled can be automated and should be automated. A lot of companies don't automate, but they typically find out after there's been a breach that automation could have prevented the breach. Understanding the NIST model, the definition is good. Become familiar with that definition. Use the tools to evaluate and compare cloud providers. If you're making a decision, then you should know who are the competitors and what are the benefits of each of those providers. Make sure there's documentation and that they publish their security controls and features. Document the project security compliance requirements. If it's an agency that has certain requirements, like healthcare and or banking industries have very strict requirements that must be adhered to. Use a cloud security process model like the one we identified to look at the design of the architecture, the gaps in control. Is there any openings that need to be that could cause a security breach, and those gaps that need to be filled? Make sure that security and compliance and controls are in place. Very important. So this has been our discussion of chapter or domain 1 in security guidance.